Welcome to MistFits Unmuted, podcast where we talk about anything we think people who like Mist, Wi-Fi, or maybe just network technology in general will find interesting. Each episode we have a different Misfit. For those who don't know, is an ambassador or pretty much a Mist Juniper fanboy, and is created to recognize our long-term supporters. And so today we have a couple of special guests. But first, my name is Robert Boardman, one of the co-hosts, and then I have my fellow co-host, Mr. Stephen Cooper.
Hi everyone, I'm Stephen, and the same team with Rob, looking after Mist in Europe.
Yep, and we have with us a very special guest today. If you don't know him, you probably should. But if you do know him, you know this is going to be a long conversation. So let me introduce Peter Mackenzie.
Hi everyone, it's nice to be here, Rob. Stephen, thanks for having me on.
So, all right, Peter, what do you want to talk about today? I was drinking water, I apologize.
Okay, what do I want to talk about? Well, personally, something that I think is a really interesting topic at the moment is how, I think for a long time we've talked about how nowadays we don't design for coverage anymore, we want to design for capacity. And we talk about capacity designs a lot, but I don't think we ever really think about how does that actually impact how we design. So I sort of feel like we've been for a long time designing the same, just putting more APs in, and therefore that deals with capacity.
AP?
Well, I think you do, but then how do you think, what about, and how does that impact what antennas we use? So I think that would be a good topic.
Oh, all right. So let's talk about it, because again, as we sit there and think about it, literally a lot of people go out there and say, I need more capacity, just throw another AP up.
Yeah.
And they don't really go into the understanding of what that actually means. And that's usually more hurtful than helpful.
I think so. And I think one of the problems is you look at all enterprise class APs over the last, 20 years, and they generally have an integrated Omni antenna into them, don't they? And, and that Omni antenna is a down tilt Omni and has been designed to be ceiling mounted, but it's been designed to give as much coverage as possible. Hence, you put it in the center of a room, it'll cover the entire room. So that's the purpose of that antenna. That's what it was designed for. It was designed to do coverage. But the problem with that is then we go, well, actually one AP can cover an entire room, but let's say it's a lecture theatre and there's 800 people in there. We go, well, we need 800 people. That's going to be too much for one AP, so let's put multiple APs in. But we don't think about the fact that all those APs cover the entire room, and we all know, don't we, what happens is everyone comes in the same door. They connect to the first AP.
And they stay there.
And they stay there, they don't roam. And then you've still got 800 people on one AP, and then you've got another 6 APs in the room doing nothing.
That's true.
So I think that's an issue that happens a lot, and we've never really, I don't think there's been enough thought as an industry into how we fix that.
And I think too many people maybe have a misunderstanding of what capacity-based designs are and their tools of choice too. So they possibly over-engineer when they're considering number of users per radio. They sort of lean a bit too far into the capacity side as to what the tool is saying you should have in a specific area for a specific number of people. And they forget the basics of the RF and the coverage side, which we're going to touch on a bit more detail.
I think so.
They don't find a balance.
I think that's it. And I think so therefore, I guess my question would be that I'd love us to talk about is maybe an Omni antenna isn't the right choice. So actually, maybe we need to start thinking, actually, if we're going to be doing capacity designs, we need to be using directional antennas.
So, yeah, but the problem you do run into that is the cost generally. When you start talking adding external antennas to, now you have a different type of AP, different types of mounting, you need another way to mount the antenna. Because it's nice to say that we want those things, but how many customers are like, here's my drop ceiling, for instance, now where do I put the antenna? Where do I put the AP? And that has been one of the barriers to entry for doing better capacity-based designs, I think.
I think you're right, and I think though, and that's why a lot of people have stuck with the Omnis, because buying, antenna cables, antennas, where do you mount it? People often say they don't want to see the APs on display. Like, if you want to put an AP and an antenna, then I'll be honest, that is ugly.
It is.
But if we're going to do, I still stand by my statement, if we're going to do capacity designs properly, we need to be using directional antennas.
Yeah, for sure. So, I mean, that's a good segue. If someone was to ask you what your ideal antenna design and an AP would be for high density indoor usage, what would it be, Peter?
Oh man, it's I really feel like, and I never normally like saying this, but it's that perfect answer of it depends. But I think it does depend because there's no two environments which are the same. So, we can think the traditional office area and density.
Yep.
And I think that's lends itself definitely to directional antennas. But actually, we're getting density in all environments. There's density in stadiums, which has always been there. You get density now in warehouses.
Yep.
You look at warehouses and more reliance on mobile devices, and they've not put in mobile devices on everything, forklifts and so
you have robots running around.
And robots running around. So I wouldn't pick the same antenna for a warehouse that I would pick for an office space environment.
That's true.
And I think so. Well, I think you might go, oh, well, actually an indoor environment, actually office-based environment, a 60 by 60 might be a really nice choice, for example. But actually, if you want to put me in a warehouse, and I might think, well, actually, I want more of the warehouse type antenna pattern where we got to...
Or that north-south.
Yeah, north-south, 120 or 90 degrees, a nice small 30-degree focus.
Yep.
East-west. So that's why I think there's for me anyway, when you look at the new Juniper AP66, I was very, very excited when that AP came out because I've been looking for something which has selectable antennas.
Yes.
Because I think you buy it and you go into an environment, and actually, even let's just take a warehouse. I've done a lot of warehouse designs. It's an environment I'm very familiar with. There's a high reckoner out there. Well, actually, we can put it in a 90 by 30 degree mode. But then there's other areas in a warehouse, and the high pallet area where maybe I want to put it in a 90 by 90 area.
Yeah.
But then I might want to beam into the truck bays with a 30 by 30.
Exactly.
So one environment, and actually I want all three options.
Because we touched on the installation of external antennas and cabling, a lot of mistakes can happen there, and finding the balance of the skills of the installer to do that properly. And you're talking about polarization of the antennas and everything, but also we know a lot of customers want to standardization as much as possible, whether it's just to simplify their rollouts and what they're supporting and maintaining. They want the one AP to support if they want to. Could be for sparing, could be for just makes it easier in their perceptive, view of how the environment's working, that they've got the one AP to work with. But when we're talking about this use case of warehouses and distribution centers, we know things can change and move as well. So if you think about the effort and design required to handle something that's frequently changing with static antennas and static positions of APs and placements, that's quite cumbersome.
Yeah,
It is. And I actually had chatting to someone at a conference. It was a number of years ago, but they were saying they did a lot of warehouse design, and they said they put in normally twice as many APs as they need.
Yes.
And that's because obviously once it's installed, pulling cables is expensive, and then they generally go in and turn off up to 50% of all the APs they've installed. So they've got kit in there they don't need.
Yeah.
And I was like,
why? That's a way.
It's a
The
way.
sales guy loves
The
that.
sales guy knows it.
If you would like to buy double APs, please buy as many as you want, and then turn 50% off and have a good design.
It's a way, but I've actually even myself, I went into, not a design I did, but into a customer where they had that exact scenario, and I went and turned nearly half the APs off.
It's actually quite common.
Exactly, that's the contrast of the other side of it, right? Where someone that over-engineers the capacity side of just even an indoor carpeted office space,
Which we've seen
and
many,
APs
many,
of-
many times.
5 to 8 meters apart when they probably should be 13 to 15 meters apart. And we help them analyze everything. We say, you need to turn half your access point radius off.
Now, if they would have had it internal directional, like a nice 60 by 60,
You can make that work a little better to where they could actually maybe get a little bit more capacity out of it.
And the thing was, what people don't realise is you can actually damage your capacity by putting in omnis.
Yep.
So let's take the high capacity office environment, open office environment, hundreds of people working on islands up desks. That's now you put omnis in there. The problem is everyone tends to walk into an office the same way, and they connect to an AP and an omni, and they don't roam. So now what happens is, not only is everyone connected to one AP, but the people who've walked away, because they're at a low signal strength, so they're getting a low modulation office, lower data rate, worse performance, but they're contending with the people who are under the AP. So everyone's getting a worse experience. So if you can have really good signal strength, but limit that cell size, because you want people to get good signal strength, especially to get modern day modulation methods like 4K QEM. But limit it so it drops off quickly so they roam when they move away. You're going to not only get a nice spread of clients across the APs, but you're going to also get everyone with high performance, because they're all going to be connected to an AP they're close to, getting a high modulation, high data rate, and you're going to get that nice performance.
And you get use out of every AP that you use instead of...
The other thing that we do see on the topic of the roaming is, people that potentially are further away from that first or second access point they've run to coming to the office, they might be down the other end of the floor in this high density spacing of APs, and they'll be statically working at their workstation for an hour or two, but their device is so confused about all the different APs around, no matter whether you've got support for edit 11K R&B and whatever, and you'll just see static workstations roam for no reason. Just because the client's confused. Obviously they make roaming decisions for whatever reason, but we want to make sure that the clients are less confused. And that's where we see an exacerbation of problems in there. It could be hidden node problems. It could be excessive
symmetry. Where you run into a little bit of an issue where we're trying to get the client, since it makes the decision, let's try to think that it has the best choice, and don't give them too many choices.
So we always say with antennas, certainly, we say that the sort of golden rule of an antenna is cover what you want while not covering what you don't want. And that becomes important for capacity. And I think maybe, I don't know if everyone listening to this podcast knows about the AP33, but it's got we've probably covered it, but it's just got 3 options, hasn't it? It's a 30 by 30, so nice, tight.
You mean the AP36?
No, the 66.
66.
What did I say? You said 33. I was like, don't sell the 33 like that.
Did I say the 30? Yeah, I do apologize.
We're going to start getting... We're going to
get going back to you.
We're going to start getting requests. How do I switch my 33 into a 60 by 60?
The 66D it is. We'll even use the D. The 66D. It's got 30 by 30, nice, small, tight coverage. Ideal for things potentially like stadiums. It's got a 30 by 90, so thin in one direction, long warehouses. It's got 90 by 90, potentially, indoor office environments. And we actually did some testing, didn't we?
Yes.
A 66 just the other day. And it was, we did the survey results, and you actually saw a nice, neat, when you're looking at that sort of primary signal threshold of mine at 65, you could actually see the antenna pattern. So when it was long and thin, we got long and thin, nice and tight. Even within one room, we got nice green coverage in under the AP. You go to the corners of the room, and it wasn't a big room.
It almost makes design a little bit more predictable too, because you're not, again, I'm throwing up a big Omni, and it's going everywhere, where I can now control that signal and say, okay, I do need 2 APs in this room, because a lot of times you'll sit there and say, hey, I have a 60-person room or an 80-person room, and you're just like, one AP fits the RF, but I need the capacity, and generally people would throw in 2 Omnis, and you're not really doing capacity. But here you could say, oh, left side of the room, right side of the room.
Absolutely, yeah.
I think that's really cool. I mean, we focus on the 66Ds so far, but I mean, we've spoken about indoor use cases as well, which we've had the AP47D for quite a while for that use case. Rob and I have spoken about that before in different events. We've also just introduced the AP36M. And we can talk a bit more about that as well in terms of directionality and flexibility. So I just want to make sure that we do cover those in conversation. But before we get there, the 66, what other considerations do you think people might have in terms of high density design, that configurable, software configurable, coverage patterns? We've talked about stadium use cases. Are there any considerations around capacity, spatial streams, are we going to get down a rabbit hole of
Yeah.
2x2 versus 4x4 or?
I think we did forget one thing before we go to spatial streams.
Yeah.
The fact that it's an outdoor IP-rated AP that's allowed to be used indoor, I think that opens it up to a use case of not only can it go outdoor, but when you, not just warehouses, but let's talk cold rooms, let's talk areas where you're really restricted, and while you're inside, an outdoor AP can be used, should be used, because then you're not putting it in a box, you're not having to go get temperature controlled areas. In areas that are sensitive, we're like having venting on the APs, like in clean rooms and things like that, having that sealed AP and being able to use it indoors kind of helps also mitigate some of the cost. Because again, external antennas work, but putting things in boxes, trying to do all those things are also, so the physical installation of it, I think, also helps a lot as well. And I think it gets overlooked a lot of times.
I think it does. And actually, I only got to see it when we did its testing.
We just got to touch it for a little bit.
I just got to touch it for a little bit. But, it's very neat and tidy. It's not a big AP.
It's not a big.
It's not like this big thing with a, I don't know if you...
Which you would think it...
Which I actually thought it was going to be.
Yeah.
But it is like maybe a bit thicker than a standard AP, but it's no bigger in dimensions.
If the audience are familiar with the outdoor AP 61, 63 that we have,
They're really big comparatively.
The product team and engineering team do a fantastic job of the 64, which is the Wi-Fi 6E outdoor one. That's quite a bit smaller form factor. And the 66 and the 66D are pretty much the same, just a little bit thicker through. But in terms of footprint, it's
really nice.
For those who know, the Wi-Fi stand for doing like AP on a stick, we had it mounted on a Wi-Fi stand, so it fitted in a Wi-Fi stand.
Yeah.
So it was a really nice size, and I think that again goes to the point of it's quite. It feels to me like it's quite versatile because, some people have made like really big, like the APs with, antennas built in, which I think are designed for one use case, which is stadiums.
Yes.
They're too big to put anywhere else.
And then
whereas this,
people try to use them elsewhere.
then you can try and use them elsewhere. Whereas this, I feel it's got that. It's small enough that you could use it in a stadium with a 30 by 30, nice, small spotlight type coverage. But you can easily put it up in a warehouse. You could easily put it up in an office-based environment.
You could put it in a freezer.
You could put it in a freezer environment. There's so many use cases for it, which I think is very fascinating.
One key point you mentioned, Rob, about this being so flexible and being able to put it indoors, outdoors, like you mentioned, is, we're not saying don't use external antennas at all in this conversation.
No.
We have talked about them before. But there is a use case for them.
Okay.
And there's certainly use cases where we've got our AP47E, AP36M. We've got a solution for 6 gigahertz where it's approved for use for that. With all these complicated, device specifications for indoor, low power indoor, very low power, standard power. The 66D helps remove some of that confusion.
Especially in the outdoor areas.
Because
you can,
the cloud platform will automatically configure what's allowed for that regulatory domain. Is it standard power outdoors? Is it low power indoors?
Very low power.
Very low power, 6 gigahertz channels. Which ones can it support? This removes another element of confusion, I think, when it comes to this new use cases for 6 gigahertz. The fact that it's software configurable, indoor, outdoor, it just solves so many headaches for a lot of people trying to understand how they can do this sort of capacity-based design and deployment in this era of 6 gigahertz.
And also with the software definable antennas, you also look when you're designing, especially in like stadiums, when you design a 30 by 30, when it's full, what do you do when you have half capacity or less capacity? You would now have the ability to take that AP and say, well, maybe a 90 by 90 would be good from what we need from a user base. And so you have that ability to say, hey, I need this today. Tomorrow I need this. So you have the options to actually reuse, make the RF better in different situations, which you wouldn't typically have with a static antenna or an Omni.
Yeah.
Yes.
Obviously, there is the 66 by itself as well, just the default outdoor, indoor.
There is an Omni.
There's an Omni version, so you can still use that if you want to.
And we're not saying Omnis are bad.
No.
We're just saying
Omnis are good when you want coverage.
When you want coverage, but if you want capacity, you want to do more directional based designs.
Yeah.
That's exactly right.
Yeah, no, so you're never going to have like a Swiss Army knife of an AP, but it's coming pretty close to that.
It's getting there, yeah.
It's pretty
It's got multiple of the functions you want in the Swiss Army. You're almost got a full one.
Yeah. So briefly mentioned before the 36M as well. This also got announced at the same time in terms of the new Wi-Fi 7 APs that Juniper announced. And that's sort of in the family of where we'd say, the mid-range or the performance end. But it's pretty high performance in terms of spatial streams. We have the 37, which is a internal Omni.
Yep.
It can do tri-band, 2.4, 5, and 6. The 37 has the directional VBLE, which we use for missed location services. There's the 36, which can just be the same thing as the 37 without the VBLE.
Yeah, it's just
if you don't have
it has the Omni BLE, so it has.
Yeah, it has the Omni BLE. Yeah. The 36M is the really nice one. This is where we're getting to again a blended use case and more flexibility in one AP approach. The 36M has the same option of a internal directional pattern 60 by 60 like the 47D.
Yes.
Or external antennas. So when we talk about the 47E with external antenna support for 2.4, 5, and 6 gigahertz, the 36M can actually use that as well.
Yes.
So you could actually solve both external antenna use cases as well as indoor or internal directional use cases with the 1AP form factor. We talked earlier about support and maintaining spares and everything.
I think it's a really clever AP.
Yeah.
Yes.
And I can see it being like, for your capacity indoor Wi-Fi designs, I could almost see it being your default AP. And I think that's for two reasons. One is, I think the 60 by 60 directional, as we've said, means that you can ensure good roaming in high density areas. But then you look at indoor environments and we're always stuck with, there's other use cases which you find difficult. Take atriums. You know, I was teaching a Hamner class earlier this week, and we get to an atrium, and I always show the problem. You put an Omni AP in, and it floods out into the atrium.
Everywhere.
It floods everywhere. And how do you do it? And I always say, well, what you want is a directional antenna pointing away from the atrium.
Yes.
So where you've got that scenario,
you can use
that's
it.
when you actually go, let's use an external antenna. And of course, every building's different. So what beam width do I want? That's probably when I do want to pick an external antenna. And I've got that. So I've got my high capacity areas with the 60 by 60, where I've got these areas where I just want to control more where the signal goes. I can use an external antenna, and you sort of get the best of both worlds. And it's the same AP.
Well, another form factor is interesting. We've all been doing this a long time, but I have seen actually a lot of outdoor or external antenna APs being sold indoors, where you'll see, well, I needed a couple of external antennas, and then they'll buy them in bulk and then just put rubber duckies on them and use them as indoor Omnis. Well, in this case, you can actually do that without having to put little rubber ducky antennas on everything, and people see those things and jump up and smack them, and now you have what looks to be that proper form factor that you're used to, but you still have that flexibility to say, hey, let's do externals. It's a very, like you said, clever. I think I like that. It's a very clever use of an AP. And again, we're getting into that Swiss Army knife where we're starting to see APs not just have a single use case. We're finding that APs need to have multiple ways of being deployed.
But I think it's also brings that flexibility, because we all like to. We would love to say that every project you do, you get to go in there, gather the requirements, do a design, work out where you need everything. But that's not real life. What often happens is there's some sort of ill-defined set of requirements in an RFP. And then they want, part of the RFPs, they want to know how many APs to buy. So, and then I think that's essentially, I don't really know whether I want external antennas or I'm going to want, you could quote the 36M, and if you get roughly the right number of APs, and then at a later stage you need to just add some external antennas, you can do that as opposed to going, now we need to swap that out for the external version and buy antennas. That's getting an expensive change. And I think for those use cases where you need to, and that happens, doesn't it? I know ideally we would like to say, oh no, everything's always planned, but in reality that happens. And I sort of feel this would be a safe AP to buy in those scenarios, because it gives you that option. And even post-appointment, you can go, actually, this one isn't working for me here.
Yeah.
I don't need to buy a new AP, I just need to buy an antenna.
And it definitely, the 60 by 60, you said it, that you're able to put that RF where you want it. And the nice thing is, if somebody does get a little AP happy and throws a bunch up there, your RF doesn't completely get destroyed. Like, we've done some testing where you're seeing having a little extra power doesn't actually hurt.
Yeah.
And you're not actually causing a lot of co-channel. You're not causing a lot of those things that could cause issues, because your RF only it's limited in where it goes.
So it's something I can get on my soapbox about this. Maybe it's why you brought it up, but
I would never have triggered you intentionally.
No, but transmit power. This is a really thing. The way some people try and do capacity is we'll put omnis in, and they recognise that it's not going to run, so we'll reduce the power. But reducing the power is counterintuitive to capacity. Because when you reduce the power, you effectively reduce potentially the data rate people are going to connect at. You reduce therefore the lower modulation method. I always say it's lower data rate, lower performance, and now everyone's competing for less capacity. Because when you lower the data rate, you have less capacity. So you're doing a capacity design, and smaller transmit power, I don't think is the way to do it. You want to have high transmit power, so everyone gets a good signal, but you control where that signal goes, and that's why
I would say balance transmit power with removing asymmetry and things like that, but not, like you said, tune it down too low, but also not go too high. You sort of want a mid-range power level which balances between AP and client.
So something sensible.
Sensible. Everyone's definition of
full watt, one watt
power is different.
But I've literally seen people go all the way down to 1 milliwatt. You end up. I've fixed wireless networks by just increasing the power.
Nothing like standing under the AP and you're still at like an 18 SNR. What's going on here?
Exactly. Yeah.
I mean, to the point of that is, I think this is also a consideration when we're doing design. We're doing capacity designs. I think sometimes we focus too much on making green circles and going, I'm lowering the power to get my circle just right. And so you could intentionally, by doing a good paper design, create a bad network.
Oh, you can.
We're turning the red Solo cup analogy is, I think, starting into the green circle analogy, where you're using software and saying, that coverage is everywhere. Let me turn down the power. It's the first thing people do, is turn down the power, instead of going, maybe I should move this AP, or maybe this isn't the right AP.
Well, that's sort of what I was saying before about people going into the over-engineering of the capacity and forgetting about the RF fundamentals, because what's the approach that a lot of people are taking is they'll start placing some APs based on primary coverage, then they'll start to look at secondary coverage. And then they'll go
tertiary coverage.
Tertiary coverage. And then they'll look at, I need to turn down my transmit power for capacity reasons, and then now I need to move my APs closer together, and then my CCI is too high, and then so people can get themselves stuck into a loop of.
Now Mr. Cooper's getting me on my soapbox about redundant coverage. See, we're here for another hour.
You're exactly right, because they start with primary and secondary, and then they do all this other stuff. What they end up doing is they can break primary and secondary coverage because they've tried to fix other problems. And actually, I always say, whether it's CCI or I need coverage first. If you get rid of all CCI, but I don't have any coverage left, then
CCI is better than no coverage?
Basically, yeah. Give me coverage first.
So you heard it here.
Co-channel is better than no channel.
Yeah.
Exactly.
So you heard it here. Peter says, have more co-channel. High transmit, lots of co-channel, external antennas.
that might be a little bit...
sponsored by Hubble Experts.
Sponsored by your local account manager.
But while we joke about that, it's not necessarily wrong in all cases.
It is in all cases.
Sometimes you can have co-channel, and that will be the best. To design Wi-Fi to work for your environment, you're going to have some, and therefore, actually, sometimes that is the best design. Yes, we want to try and minimise it, co-channel, but sometimes you can't. And therefore, and that's okay.
I think you said it best. Cooper, about it. Sometimes we over-engineer the network, where we go into we go so deep into what we think the science of it is. Like we've seen things like, well, I want 20 clients per AP. I only want 30% utilization of any one radio. I need, I have 4 devices per person, and then it turns into this math formula. And next thing you know, even internal directionals cannot save you.
Yeah.
No.
So,
I think we've had some pretty good discussion without going too deep down the rabbit hole. Otherwise,
Yeah,
we'll
yeah.
be here for
I
hours.
was gonna say soapbox time.
Maybe we need like a marathon webinar. We can just like dive deep for 8 hours.
We'll just do a live stream where we just grab people on and we all just hop on our soapboxes and rotate.
So part of the Misfit podcast is that we do get some questions submitted by other Misfits, other members in the community as well, specifically for Peter to address in this particular topic. So shall we start tackling some of those?
Yeah.
Yeah.
So I think the first one, I'm actually going to go with the second one first.
Okay.
Would it be possible to have software-defined directional antennas in the indoor APs? What would be the implications? Which we have actually touched on.
I think we've probably answered
Yeah,
this. didn't
I think we
were
did
going
that.
down
Yeah.
that AP66D outdoor
Can be
indoor.
used indoors.
Yeah,
So
Can
yeah.
be used indoor, and
Absolutely.
I think the answer is yes, simply,
Yes.
and I think we probably should.
Well, that's why we did it.
Yeah.
We've got the multi-modes that you can do in the 66D, but then that's why we have the 36M.
Yep.
M means multi, for that indoor use case of either the internal directional or the
I
external.
mean,
antennas.
with that 90 by 30 now, does that mean we start putting APs in hallways?
No.
But I have that nice long.
I think we saved the best question for last. So the first one I think we'll leave to the last
Okay,
because of that
okay.
radio resource
Yeah.
management and things. So in terms of Juniper designing these directional APs, so we had the AP47D which came out last year, 66D as well as the 36M this year with the directional patterns. The question was, did anything have to be adjusted in terms of our radio resource management algorithms in MIST? And how does that really work in terms of mixing omnis and directionals in an environment? So that's a good segue into us having a discussion about when you should or shouldn't mix these. But I think the first part of the question
First
is
part is the ROM bit.
Yeah.
RRM.
Which is,
How does the RRM work?
well, yeah. I
Yeah,
think
how does Mr. RRM work?
let me
The
tell you
Juniper
both.
people will ask you, our Juniper people will ask you how Juniper
Well, I'm
RRM
happy
works.
to actually answer the question, actually.
Can I preface it? Every MIST AP has their client-serving Wi-Fi radios. Every MIST AP, wall plate, indoor, outdoor, has a dedicated scanning radio,
Yep.
which we do use for radio resource management. The client-serving antennas on the 47D, 36M directional, and the external antenna AP models, and the AP66D, the scanning radios still use an omnidirectional antenna.
Yeah. So I think to answer the question, I think that's okay.
Mm-hmm.
Does it change the algorithm? I'm going to say yes and no. And the reason I'm going to say no, I don't think it changes the actual computerized algorithm, but misuse it, machine learning.
Yeah.
So by default, the algorithm's changing all the time.
Yes.
Because it's learning from the environment and learning what to do, and it doesn't just uses a reinforcement learning algorithm. So the beauty of it is it's not, a lot of our own algorithms from a lot of other vendors are based upon how can I hear other APs, and I suspect that's what people, but that's not, MIST has never been, or their focus has always been client performance, so client capacity, and one of the SLEs in MIST is a capacity SLE, and what basically a reinforcement learning algorithm does, who don't know what it is, you make a change to some sort of environment, and then you monitor that environment and get back an answer, was it a good or a bad change? And the way MITS does that is says, are my clients, do they have more capacity, do they have less capacity, are they having a better experience? So if you're always looking at it from a client experience, you can, even now we've got directional antennas, it's the same question, isn't it? If I've made a change,
Was it good, was it bad?
are my clients performing better? And if it was a bad change, I'm not going to do that again.
Yep.
If it's a good change, I'm going to learn that's a good change.
Yeah,
So I think, does it change the algorithm? Well, only because it's learning, and it's going to learn what good changes are. But it doesn't fundamentally change how the MITS RRM work.
Yeah, I was going to say that I don't think the RRM changes because it's always been based on the user experience.
Yeah.
So all you're doing is changing the RF, but the RF was always changing already. It's
Well, here's a level set in terms of MIST product history. Yes, we have new APs coming out with more directional patterns, and we've talked about how we could use these instead of external antennas for that same directional use case. we had Mr. AI RRM back when the AP43 came out with the external antenna support. We didn't change the algorithm then.
No.
We had the AP45E come out.
When the
and
30 was out.
Exactly.
It was
Exactly.
still.
Exactly. So,
It doesn't need.
you know, it's those APs had the external antennas that could be omni or directional, highly directional. But those scanning radios were still always the omni scanning radios, and the algorithm was still using the data and
The algorithm
environment.
always evolved, but I don't think it changes the method.
Just specifically because of
and
the
how
No,
it's-
the method.
The method is going to stay the same.
And that's what's so good about using a reinforcement
Yeah.
learning algorithm and basing it on client experience, because you do a change that affects your clients negatively. You learn from that, and it's all
Exactly.
about, RMM is all about improving the client performance. It's not about improving the RF,
Yeah.
which I think some of us are.
Yeah.
It's all about, can I make my clients have more capacity, more availability, better performance? And I think when that's the focus, I think it's really smart.
Yeah. Moving away from neighbor APs to the client is, I think, it's one of, RRM is probably one of my favorite features in our product. That, well, the other one's another podcast. So,
All right, do we want to tackle the
a good question.
Go for it.
the best last question?
Okay.
Oh, what question could this be?
If anyone's paid attention to some of the details, we don't necessarily pay attention to those sorts of details all the time, because we know generation by generation things always improve, and the benefits of a platform such as Mist is not necessarily driven by the hardware. It can be, but in terms of spatial streams, we talked about the 36M. It's
Yep.
actually quite a highly capable indoor performance AP. You can do 4 spatial streams. It's got the internal directional, external antenna support. 47, 47D, 47E, that's obviously our flagship AP, which can do
Yes.
4 spatial streams, dual 5 and or dual 6, depending on which area of the world you are in.
Yeah, which country and spectrum you have.
We talked about AP66D. It's very flexible. Indoor, outdoor use cases, high density, large public venues, stadiums. What's your thoughts around 4 spatial streams versus 2 spatial streams from like a high density and high capacity use case? Like what's the considerations? Are there any considerations for what we've talked about today? I know you say it depends, but it depends why, because of why. But we get this question a lot.
Yeah.
It's a fair question, but we've talked about this balancing act of not only the deployment costs and complexities and installations of external antennas. They certainly suit that when it warrants it, and you've got the time and the effort to have the installers trained up to do those things properly. This is another end of the cost-benefit equation of a Swiss Army knife AP in a nice form factor. What are the considerations around it not being 4 spatial streams?
I think I view this question, and basically the question is, do we, to some extent, do we need 4x4 when clients are 2x2?
Yeah.
That's the question. I guess.
That's the real. That's
That's
the question. Yeah.
And I think when you look at this question, I see it a little bit like an onion. Okay, and an onion has lots of layers to it, doesn't it? Cut into an onion, there's lots of layers. And I think it's a little bit like it. You can answer it quite simply, but then when you want to dig a little deeper into there, you strip back another layer of the onion, and you get but so you could, so if you start out at that very simple layer, you could go, why do I need 4x4 APs? Because all my clients are 2x2, so the clients are only going to, and 2x2 seems to be what all clients are standardising on.
We kind of standardise on.
Yeah, there was a point where we had some 3x3, we had some 1x1s, but clients tend to be, most clients now, if you look at Monday, clients are 2x2. So it's never going to talk, a client is never going to talk 4 spatial streams to an AP. Therefore.
Well, what about the AP to the client?
So it's never going to talk more than 2 spatial streams. So you could argue on that this is a simple layer of the union. We don't need 4x4. Strip back a layer of the union, okay, and go to, well, you say that, Peter, but let's counter argue that and say that MIMO, having multiple antennas, spatial multiplexing, which gives our spatial streams, is only one thing we can do with it.
Yep.
So having more spatial streams allows me to do something called maximal ratio combining, which is a receive diversity technique where I can basically receive on all antennas. So if I've got an AP and I can receive on all my spatial streams, I can receive and hear the client signal better.
Yes.
So when you get these clients operating at a really tiny power level, I can receive their signal and I can effectively amplify it by receiving all my streams, and I can hear it better. And obviously, because generally APs have better antennas anyway, they're better at beaming the signal to the clients, so you can actually improve your overall link quality.
Yeah.
And I think, so that's definitely true. So why buy a 4x4? For one reason, you can argue that now
You'll get better performance?
You can get better performance, but you can strip back the
Another layer.
onion again, and we can come in with another counter argument, and this is where this debate could go on forever. So stop me when you want me to.
This is a big onion.
This is a big onion. So then comes the argument. Well, okay, so you're saying we can make our APs hear better, Peter. Okay, that's a really good argument, Peter. But
So lower your power, correct?
I don't want my APs to hear better because I've got high density, co-channel contention. You're making them hear better. They've got more chance of hearing other pairs APs on the same channel. You're going to increase your CCI. I don't actually want that in modern day designs. So you go, oh, okay then. So maybe I don't want it. And then and then you strip back another layer of the onion, and then you go, well, you say that, but actually, when you look at the sort of flagship APs, they're always 4x4. They don't only have 4x4 radios, they have the better memory, the better processing power, and when you're doing high density, you want to be able to associate all those clients, and you want to be able to handle that. Generally, the 4x4 APs are better at that, and you can keep. I feel it's a debate. I've been sat in rooms where hearing people debate it for
it's
a
a
long
fun
time.
debate to watch.
It's a fun debate to watch. So, I think it's. I don't think there's a simple answer.
It's not a simple answer.
There's no simple answer to that question.
You need to understand all the aspects of it.
You need to understand all those aspects. It's not just as simple to go, we've only got 2x2 clients, let's buy 2x2 APs. That's not
Well, that's the thing.
the
I
simple
see that
answer.
a lot.
So your answer is it depends?
Well, it seems like a one-sided consideration a lot of the time is people talking about the clients, and like what you described, it's actually more in the receive end of the client or the AP. Some people are still hung up now on the transmit supposed benefits of MIMO. We all got pitched on transmit beamforming and downlink multi-user MIMO, which requires a lot of overhead. And yes, in theory, additional special streams could help with that. I think a lot of people still have that in the back of their mind going, oh, I need more special streams to help the downlink from the client, from the AP to the client. But it's more about the receive diversity that you mentioned, maximal ratio combining. And I think from what we've seen from indoor environments is there's definitely the benefit of 4 special streams in that AP receiver in terms of a high multipath environment, which is your typical office indoor space. Maybe it might be in warehousing, but not so much. But when you think about the AP66, it is an outdoor AP, but it can do indoors. We don't see a lot of effects of multipath in the receive direction outdoors. There's not as many things to reflect of, obviously. It's going to be environment dependent.
Another thing you can bring up is the fact that, with those 4x4s, you actually kind of can improve retry rates too. You start to see less retries because, again, you have more ways to receive. And so but again, is that nominal change enough to say, I want to spend more on a 4x4 AP? Because there's also the cost factor too. There's another layer to that onion.
I get, and this is why what I would say is don't try and look at it's almost the question's wrong. Don't try and look at should I be going for a 2x2, 4x4, which is best. It's like which is the most appropriate for my environment and my needs. Everything always should come back to requirements. There's reasons why I want that extra receive sensitivity. And I need that in my environment, and that's going to be good. There's at times when you actually might go, well, actually, a 2x2 will be good enough and actually be what I need in this environment. So it should ultimately, you should know the difference. You almost need to know the argument so you can go, well, actually, which bet suits my requirements? And it always comes down to requirements.
And it might change site by site. It's like, I do always see one thing that I'd like to see us move away as an industry is you'll peak up, okay, I've got 2,000 APs in my environment. I'm going to buy the one AP for all 2,000. And it's one of those things that, like you said, this building might want it. That building might just have 2 people in it. And you're just like, okay, I can do a 2x2. I don't really need the benefits of that. There's no density requirements. And so, yeah, it's an interesting.
So obviously that's 4x4. When are we going to see 8x8 APs?
Ooh, 16x16.
No, 16x16. So I guess, and I threw that in a bit as a joke, but I don't see us ever going there. I think 4x4 is
Just
probably,
like clients have kind of settled
it's
on
been
2x2.
tried in the market.
it's been tried,
and it's not been
and it's
useful.
not been useful.
Yeah.
So I think 4x4 has been proved to be useful for some cases, and I think that's why you're going to keep seeing it. It is very good in some environments.
And I think from the directional use cases, especially with the 66Ds, and we're talking about narrowing that pattern to 30x30 and 30x90. I wanted to correlate that back to us discussing about the receive direction, maximum ratio combining, versus the indoor multipath. If we're using this in an environment that's not expected to have as much multipath, and the signal in the receive direction and the transmit direction is tighter, would you agree that maybe 4 special streams is not needed?
Sometimes
Because you're reducing the effects of multipath or any combining of received singles from different phases in it
there's definitely
with a directional pattern, because the directional aspect is in the receive as well as the transmit.
I think there's definitely times when a 2x2 would be absolutely fine, and maybe even preferred.
Yeah.
I think, but then there's definitely times when 4x4 is needed. I know some like warehouse environments where there's lots of metal racking, lots of multipath, and when you look at the clients, some of these mobile clients, like some of these old mobile printers that are using, they're terrible Wi-Fi clients. That you get very little signal transmitted from them. And they're often maybe on a belt clip around metal cages.
In a forklift.
Or in a forklift. And actually having that received identity, you need it. If you put 2x2s in as well, it really doesn't perform very well. And I've seen both. So
which is why the 47E exists.
Yeah.
So
there is all these. It is about going to what's your use case. Because if you understand the use case, you can understand which is going to be best.
Yeah. Cool. I think we've squeezed as much about directional and capacity designs into 40 or 50 minutes than we can. Otherwise, we'll go on forever for another time.
Like I said, we're going to pull our soapboxes out. We're all going to hop on them.
Yeah.
Great. Well, thank you so much, everyone, especially Peter, for joining us as a guest. And thank you to my co-host, Rob. And thank you to you all listening and watching for joining us on this MistFits Unmuted podcast. So we'll be having some more episodes coming out with some other great special guests talking about different topics. For this episode, the recording will be up on YouTube. It'll be on all your usual podcasting platforms like Spotify and Apple Podcasts. So please subscribe and let us know what you think. And if there's more information that you wanted about what we discussed today, reach out to any of us on LinkedIn or directly by email if you have it. And if you're interested to hear more about what's upcoming and even just being a part of the MistFits, please feel free to email mistfits@juniper.net and someone will reach out to you.